Good morning to one and all. I am from mechanical engineering. Today my topic is about structure aware stable diffusion for traditional architectural decoration design. Introduction to traditional architectural design decoration. Traditional architectural decoration reflects the cultural heritage of regional identities. It involves intricate patterns, motifs, structural elements. Modern app designs integration requires innovative approaches. Challenges in traditional decoration design. Maintaining structural integrity while designing ornate details is complex. Digitally replicating traditional motifs can lead to loss of authenticity. Ensuring design consistency across large scale projects remain difficult. Overview of stable diffusion models. Stable diffusion models are generative AI techniques used for high quality image synthesis. They progressively define images through a densoning process. In denoising processes, these models have shown success in creative and artistic image generation tasks. Limitations of existing diffusion methods in architecture. Traditional diffusion model lacks awareness of underlying structural constraints. They often generate visually appealing but structurally inconsistent designs. Incorporating operating domain specific knowledge remains a challenge. Concept of structure aware diffusion. Architectural analysis. Structure aware diffusion integrates architectural structural information into the generative processes to the model to the produce designs that adhere to physical and static constraints. This approach ensures both aesthetic quality and structural feasibility. Relevance to traditional architectural decoration. The method helps recreate authentic motifs with structural coherence. It supports the preservation of cultural elements in modern reinterpretations. Re- Reinterpretations. Designers can generate diverse options aligned with traditional styles. Core components of structure-aware stable diffusion. Structural encoding that captures key architectural features. Conditions generative process that incorporate structural information. Feedback mechanisms to refine generator designs uh, iteratively. Structural encoding techniques. Use of graph-based representations to model architectural represents. The represents of architectural elements to the symmetry and hierarchies using the embedding of structural into the knowledge like symmetry and hierarchies. The graph representation models architectural elements. Use of graph-based represents to model architectural elements. Incorporation of domain knowledge like symmetry and hierarchies. Embedding of structural properties into the diffusion process. Conditioning the diffusion model. Structural information serves as a conditioning input during generation. It guides the denoising process towards structurally consistent outputs. Condition improves the fidelity to traditional motifs and patterns. Model training and data preparation. Training involves data sets of traditional architectural decorations with structural annotations. Data augmentation enhances model robustness and diversity. Transverse learning accelerates adaptation to specific regional styles. With the model analysis and the robustness to the diversity and decoration with structural annotations to the adaptation to specific regional styles. Implementation workflow. Collect and reprocess traditional architectural motif datasets, encode structural features and integrate to The diffusion model generate and refine designs through iterative sampling. Case study: designing temple facades. The model generates facade patterns respecting structural and stylistic constraints. It captures aesthetic carvings and ornamentation authentically. Results demonstrate high fidelity to traditional temple architecture. Benefits of structure-aware diffusion and design. Produces culturally authentic and structurally feasible decorative elements. Accelerates the creative process for architects and designers. Facilitates preservation efforts by digitally achieving traditional motifs. Limitations and challenges. High quality structural and notation data can be difficult to obtain. Balancing aesthetic diversity with structural constraints requires careful things. Computational complexity may limit real-time applications. Future direction in research. Integrating 3D structural models for comprehensive architectural design. Developing user-friendly interfaces for designers to interact with the model, extending the approach to other forms of cultural heritage preservation. Practical applications in architectural design. Customizing traditional motifs for modern building facades. Restoring damaged or incomplete historical decorations digitally. Enhancing virtual reality environments with authentic architectural details. Impact on cultural heritage preservation. Digital tools assist in documenting and recreating traditional designs. They support educational initiatives and cultural dissemination. Promote sustainable conservation through AI-assisted design. Conclusion. Structure-aware stable diffusion bridges traditional aesthetics with modern AI technology. It ensures design and both culturally authentic, structurally sound. This approach opens new avenues for innovation in architectural decoration. Summary of key takeaways. Incorporating structural awareness improves the quality of generative designs. The method supports cultural preservation and creative freedom. Continued research will be enhance functionality and accessibility. To the method supports cultural preservation and creative freedom. To the continued research will enhance functionality and accessibility. References include relevant academic papers, articles, and sources related to the stable diffusion in architectural design and cultural heritage preservation. The method and support are also calculated to the preservations and cultural preservations to the creative freedom. The initiative incorporating structural things were made the quality of generative AI designs. Continued research will enhance functionality and accessibility is clear to mention the thing. References include relevant academic papers on the cultural heritage preservations related to diffusion, architectural design, and cultural heritage preservation. Thank you.